Welcome back to Green is Good, and we're honored to have with us today Michael Sund. He's the Vice President of Communications and Investor Relations for Maxwell Technologies. Welcome to Green is Good, Michael.
Thank you. Glad to be with you.
Before we get talking about your employer, Maxwell Technologies, let's talk a little bit about Michael Sund. What was your journey in your life like prior to joining Maxwell Technologies, and what led up to you joining them?
Well, I began my career as a journalist. I studied journalism in college and began in the newspaper business, and later gravitated to the world of corporate communications, I guess you could say. So I've been on the agency side and on the corporate side for more than 30 years. Got
it. And how many years ago did you join Maxwell?
I'm just about to celebrate my 15th anniversary with Maxwell.
Wonderful. So obviously it was a good marriage and a good choice.
Oh, it's been a great experience to be involved with Maxwell.
Well, let's talk about Maxwell. But, before I ever started studying them, because I knew you were going to be our great guest on today's show, I didn't hear much about them. Can you share the Maxwell Technology story and who they are and what they're doing and why they're helping to make the world a more sustainable and greener and better place?
Well, Maxwell's primary business is in producing energy storage and power delivery solutions based on a relatively novel technology called ultracapacitors.
And can you explain what an ultracapacitor is? Because I've never heard of one. I'm sorry.
You're in the majority in that regard. We use batteries as a reference because everyone's familiar with batteries, and they've been around for 150 years. Ultracapacitors are in some ways battery-like, but they have some distinct differences from batteries. So let me explain a little bit.
Sure.
Ultracapacitors charge and discharge in as little as fractions of a second, much faster than a battery. And they use an electrostatic energy storage mechanism as opposed to a chemical reaction, which is what makes batteries operate. And that creates some differences in the way they perform. So rapid charge and discharge, very long life because there's no chemical reaction, therefore no chemicals to deplete. So as you know, batteries have a finite life and need to be replaced. Ultracapacitors in many applications will last the life of the application, don't need to be replaced.
Right.
And because they don't rely on a chemical reaction, they work normally at very high and very low temperatures. Everyone knows batteries tend to struggle when it gets cold, for instance, starting a vehicle in the morning. On the other side of it, batteries have very high energy density, meaning they store a lot of energy, a big reservoir of energy. Ultracapacitors store much less energy, but they, in many ways, they complement ultracapacitors because they charge and discharge very rapidly, operate normally over a wide temperature range, whereas batteries have this large reservoir of energy for sustained energy output from minutes to hours.
Got it. So what would the benefits? So the benefits of the ultracapacitor and why people want and need to use them, and the return on investment. How does that work? Can you help share the analysis of benefits and then return on investments in their applications?
Yes. Well, if you think about the primary application for our products today, the number one is in braking energy recuperation in hybrid transit vehicles. So if you think about stopping a vehicle, let's say a transit bus that stops every block or two, every time it does that, if it's a hybrid vehicle, it has an electric motor, and instead of using friction to bring that vehicle to a stop, the software signals the electric motor to run backwards, and it stops the vehicle with resistance. And while it's running backwards, an electric motor is a generator. And if you have an efficient storage system, you can convert kinetic energy, the energy of motion, into stored electrical energy that can be reused for propulsion. And that would reduce fuel consumption because that recaptured energy actually takes the place of the fuel that normally would be propelling the vehicle.
Okay. And so you're saying in many applications, an ultracapacitor is working in tandem with a battery.
That's correct, yes. The battery is a great reservoir of energy, but you can imagine in a braking system, it only takes, 5 or 10 seconds to stop a vehicle.
Right.
And as we all know, charging a battery for 5 or 10 seconds doesn't really store much energy in that period of time, whereas an ultracapacitor can fully charge in the few seconds that it takes to stop a vehicle.
Oh, I gotcha. So has this whole green revolution and the evolution of us driving now hybrid cars and green cars, has that been a boom for Maxwell Technologies?
Yes, it's been a great opportunity for us. So the number one consumer of our products is in hybrid transit buses in China, where air quality, as we know, is a big issue. And everywhere in the world, reducing fossil fuel consumption is a strong impetus. And so the ultracapacitor's ability to in essence, capture energy that otherwise would be wasted in a friction-based braking system and reuse that energy is beneficial to the environment in the form of reduced emissions and, of course, in payback, as you talked about, in reduced fuel consumption.
Wow. And but Maxwell has been around for more than 45 years. What was the ultracapacitors being used for before this hybrid revolution and evolution towards hybrid vehicles? What was your core competency in terms of use and applications years ago?
Well, ultracapacitors have only really been a mainstream commercial product for the past 15 years or so.
Oh, okay.
Maxwell's main business prior to that was as a contract research and development, call it a laboratory, operating under government contracts and so forth. And one of the initiatives during that time, when Maxwell was essentially an R&D company, was in developing this infant energy storage technology called ultracapacitors.
Ah, got it. And by the way, for our listeners out there, we've got Michael Sund with us. He's the Vice President of Communications and Investor Relations for Maxwell Technologies. And if you want to follow along as we have our chat today here at Green is Good, you could go to www.maxwell.com. It's a beautiful website. I'm on it now. There's a ton of great information on everything that Michael's discussing with us. I mean, and all the great applications that Maxwell's doing to green the world and make the world a better place. So UltraCaps is something that was part of the R&D work of Maxwell and has now become one of the linchpins to this whole hybrid revolution.
Yes, that's correct. We're becoming more familiar now with so-called stop-start idle elimination technology, which is we're not talking about electric propulsion of cars. We're talking about saving fuel by turning off the internal combustion engine when it otherwise would be idling, such as at a red light or in stop-and-go traffic. And that constant restarting, you can imagine during a commute, you might have many, many opportunities to turn off the engine, and that requires a restart each time. So in the auto industry, the first application for ultracapacitors was in providing cranking power to continuously restart a vehicle and allow it to save fuel and reduce emissions.
And so you said one of your big clients is the bus companies, the hybrid bus companies from China. Where else are your UltraCaps being applied in the United States and around the world?
Well, our first automotive customer is the French automaker PSA. They make the Peugeot and Citroën automobiles in Europe, and our products are in more than 1 million Peugeot and Citroën cars today, again, helping them to restart and save fuel. The largest bus maker in the world, based in China, is called Yutong. So they are the single largest consumer of our ultracapacitor products. We're also providing ultracapacitors to wind turbine manufacturers globally. Our first customer was a German company called Enercon. And we also service large Chinese wind turbine producers such as Goldwind. So those are some of the largest consumers of our products today.
And explain the connection with wind and grid energy storage. Is there a connection with solar and wind and what you do with ultracapacitors?
Yes, there is. And let me explain first. Our longtime association with the wind industry began in something called the blade pitch mechanism of a wind turbine. And simply, that means that these wind turbines can damage themselves if the wind blows too hard, and so they need to be able to pitch the blade of that wind turbine into a neutral position when wind velocity is too high. Ultracapacitors are used to deliver a burst of high energy to accomplish that alteration of the blade pitch. As we look to the future, renewables such as wind and solar are inherently variable. A cloud passes over a solar array, wind velocity fluctuates, and ultracapacitors can be used to smooth the output from that renewable source into the grid, which likes steady input and has difficulty providing reliable service to you and me if the inputs fluctuate too much.
Is that already is your ultracapacitors already at work due to the California Renewables mandate?
Well, we last year received a grant from the California Energy Commission to develop a demonstration project putting ultracapacitors together with a solar array to, again, improve the consistency of the solar array's output into a microgrid on the University of California, San Diego campus.
And if that works, then that's a paradigm that can be then replicated if that works?
Yes. Well, as you know, California has mandated that a third of our energy production here must come from renewable sources by 2020.
Right.
And that's a significant challenge for the grid, again, to manage consistent output with variable inputs, with a high percentage of total energy production coming from renewables. We've already seen this in Germany and other places in Europe where renewables account for a very large proportion of energy generation. And so the management challenges that come with that present a real great opportunity for ultracapacitors.
How big is the ultracapacitor world? Is Maxwell the leading brand in the world for ultracapacitors, or are they 50 competitors of yours now? How does that work in terms of your competition?
I would say we are a leading producer. In certain categories, we would be the leading producer for applications in transportation and looking at the grid. We are the leader. We have some Asian competition in applications in things like consumer electronics, where Maxwell doesn't focus its product development efforts. So, but the whole business is fairly new compared to batteries, the main energy storage technology. And so I'd say that probably the total worldwide market is certainly less than $500 million today, whereas the battery industry is tens of billions or perhaps $100 billion.
Wow. So, but the ultracapacitor market is growing, I take it?
Growing very rapidly. Maxwell, with its ultracapacitor business, has seen compound annual growth in ultracapacitor sales approaching 40% year after year for the past 5 or 6 years.
Wow. And so, does any of the U.S. car companies use your ultracapacitors? Like you said, the French company does. Does any of the U.S. car companies use it yet?
None are in production, but we are engaged in development activity with auto manufacturers and with tier one suppliers to automakers globally. And so I would say that we're very optimistic that we will be able to talk about applications with U.S. autos in the not too distant future.
What I know you work with education facilities, SOTEC and UCSD. Share a little bit about what else you're doing there. Was that the grid energy storage program, or is there other things you're doing also?
Well, SOTEC is a leading producer of solar arrays. They use a particular solar technology called concentrating photovoltaic. And so Soitec has installed solar arrays at University of California, San Diego, which is striving to become energy self-sufficient, if you will, or more self-sufficient. And so making those solar arrays more efficient and consistent in terms of inputs into UCSD's microgrid is the role for ultracapacitors. And we will be working with Soitec on a larger installation in the California desert as we move forward with this California Energy Commission sponsored program that I described earlier.
We're down to the last minute or so. What's the biggest potential that you see and the leadership at Maxwell Technologies sees for ultracapacitors to grow your market share and to grow your sales in the coming years?
Well, the biggest consumer of energy worldwide is transportation. Mm-hmm. And so making that transportation more efficient, recapturing braking energy, and helping to reduce consumption of fossil fuels, and then the whole realm of energy generation, as we've talked about. So the transportation and the grid offer limitless opportunities for our products.
Got it. Thank you, Michael, for joining us today. For our listeners out there that want to learn more about Maxwell Technologies, go to www.maxwell.com. Thank you, Michael Sun, for your wonderful energy and sustainability work at Maxwell Technologies. You are truly living proof that green is good.